Hello everyone, today I will be presenting image generation and separation using Stable Diffusion. Stable Diffusion is a text-to-image model, but also it can be used for many other things like image-to-image translation and also Inpainting and separation. So I choose to use that notebook on Kaggle, to run that code on Kaggle because Kaggle we can use a GPU, powerful GPU like P100, which is enough to run diffusion models. So here all what we need to do is to select that P100 and that's it. First thing we need to do is to run the first command, which will install the necessary library: PyTorch, NumPy, OpenCV, Diffuser, which is the library that will allow us to use those models, and DAAM. This is the model or the library that will allow us to extract where is each object in the image, transformers for the text model, and also Gradio for the UI. After that, what we need to do is to run the second cell, and this is here there is all the functions that will handle the image generation. Actually, it will create a server, and it will give us here the link. We can use that link to access the UI from the browser. So let's wait. This is going to take some time to create that server and load the models. So now the server was created. So as we see here, there is a private link, there is a public link, and this is going to be available for 72 hours, which is enough. And also, the UI will be also available in the notebook, so it can be used. But I prefer to not use it in the notebook because it is small. Instead, I will click the public link, and here we can see that the app is running on full screen. So let's have a look at the tabs of that application. So the first tab is Inpainting, and here we can do text to image, and we can also Inpaint. And here we can get attention maps that we will explain later. So let's start by explaining what is Inpainting. So text to image generation is to generate an image from text. So this is the prompt, what we want to be in the image, and this is a negative prompt, what we don't want to be in the image. This is the inference steps. The higher, the longer the generation will take, and the better, but usually a number of 30 is enough. Guidance scale control how much the image generated is going to be related to the prompt that we entered. Higher will cause the image to be more related to the prompt that we entered here, but a number like 7.5 is enough. Now let's try the Inpainting model. And by the way, the Inpainting model can do Inpainting and text to image generation because all of them are based on Stable Diffusion. The only thing is how actually the process is done. So let's start with an image here. So I have this image. So here there is a brush that we can select and select the size. So here, for example, we can remove that motor. Here we can see the mask. We can also use some blur to make it smoother. So let's keep it 10. And yes, the white area is the area that will be removed. And here we can specify nothing. We just want it to be a high resolution. We can also specify what we want to be instead. So instead of motor, we can specify here like horse, and he will replace the masked area with a horse. But now let's just replace it with anything. So this is going to take some time, and this is because the request is handled in Kaggle here. Here we can see that the request is handled. This is the result that will be shown here. So as you see, he replaced the old motor with a new one. So it's completely different, and also it looks realistic, while it kept everything else like the rider, the background. So everything is good. Also, we can do another thing, which is instead of doing Inpainting, which is removing the motor, we can actually remove everything except the motor, just by specifying here invert mask. Keep that mask smooth. like 12, and then we can run it again. So now it will remove everything except the motor. Here the request is handled in Kaggle. So as we see, a request take almost 10 seconds on a GPU. In CPU it take more than like 5 minutes. So as we see here, this is the motor, and it was like remove everything except it, and also put it in like a realistic context. So this is how the inpainting is done. We can also use that for like text to image generation. So for that, all what we need to do is to specify what we want here. It is good to keep that high resolution, high quality, because it makes it give more details to the image. The more detail we enter in prompt, the more like the better the image generated will be. So to do the text to image generation, we just need to specify it here and disable that mask. And yes, it's good to like check that update attention map, because if we want to get the attention map related to each of these keywords, we will need to check that. So I will check it, and then let's write. Now the request is running, and after that we will see the resulting image. So this is a good image. We have an astronaut riding a horse. Yes. So now let's do the inpainting using the attention maps. So we can move that image here, disable text to image, remove that part, and remove or uncheck update attention map, so we can keep using the same. Now we can go to the other tab. Here is the prompt that we entered. We select the object that we want to get the attention map for and put it here. So this is the attention map for the astronaut. We can load it, and we can also blur it to make it more soft. And now we can remove that object from this image. So as we see, the astronaut was changed or was replaced by another man wearing like different clothes, different hat, and also the horse was not changed, the background was not changed, so only that part was changed. We can also actually like change the object that is in this part with a specific element. For example, we can like change it with instead of like generating any random content, we can like specify here like a doctor, and he will replace that part with a doctor. So as we see here, he managed to replace the object that we want to remove based on the mask getting from the attention maps with a specified element, or just by any like realistic content. Let's try with another command. Now we can disable text to image generation and move that image here. Okay, now let's go and get the attention map for lemon. So this is lemon. We can load that attention map, make some blur, and here instead of a photo of a lemon cake, we can, for example, just remove that object. So as we see here, the lemon was changed with another one. We can also like replace it with something else, like say pineapple. So here we see that yes, he managed to replace the lemon with a pineapple. It managed to remove the object and give a realistic content. We can try it with another command. So this is like a good generated image. And here we can replace that orange with any other thing, like a glass of apple juice on the table, and load attention map. Yes, we can here either replace it with another object, or just remove it, and he will fill it with anything like any content that will be good with the other component in the image. I don't know if this is realistic or not. Let's try another one. So as we see here, when we ask it to remove that object, he removed the orange, and he filled it with something here like cold water. So this is the table. We can load its mask. We can make it softer. And okay, let's remove the table. Yes, so he managed to remove that table and replace it with I think this is a piece of wood or a book, and this is also like a piece of wood, like segment the grass. So this is the map of the grass. You can make it smoother. So we see that he managed to replace that grass with another grass, like with another background, while he kept the table, the cup and the other parts like almost unchanged. And here he changed the background. If we want to change that background with another specific background, we can just write it here. We can replace it with let's say on sands. So he managed to like replace that old grass with a new grass. He filled here with new content. Now there is a new type of tree. There is some stone here. So as we see so far, the model that we are using managed to like do the inpainting, the outpainting, also text to image generation, and also when we are generating an image, we can get the attention maps, and using those attention maps, we can use them to like to get the mask or the segmentation mask. And using that segmentation map, we can use the text guided inpainting or outpainting. I hope you enjoyed that video, and thank you for your attention.